Good afternoon to you. Mark Stott of HurricaneTrack.com here with your Elsa update for the afternoon of July 3rd, 2021. I hope your Saturday is going well. Let's take a look at what's going on out there with Elsa today, and we'll start off with a meme. I was about done with all the Elsa memes, so I wanted something a little bit more cerebral and intellectual. So I offer you this, a word, climatology. If you saw this movie Tenet last year, you know what I'm talking about. It was a cerebral movie from Christopher Nolan. It's one of those movies where you're like, what the heck did I just see? But in all seriousness, this helps me to explain what's going on here. And the line is that we're showing here is when he says, all I have for you is a gesture coupled with a word, Tenet. And in this case, we had Kari, one of our supporters on the back end of our graphics department, helping out. And the word is climatology. Now, why is this relevant? What am I talking about? I'm talking about this, the climatological chart of a typical hurricane season. And this is important to what's going on with Elsa. Look right here. We're in the early part of July, right there, and I'm going to zoom in and show you what I'm talking about. This will really help to prove my point. You come into the hurricane season, and the yellow is typically the instances of hurricane activity right there. See, that's hurricanes. The red is combined tropical storms and hurricanes. So you enter the season, and there's a little bit of an uptick, a couple of little bumps here. But right there, that is early July. That is very flat. It's flatter than just a few days prior. And it's almost the flattest of all of the month of July. In other words, you don't get much lower activity than that. That, folks, is climatology, the aggregation of the weather over a long period of time. Normally in the month of July, you don't see hurricane activity in the Eastern Caribbean. And so there's a reason for that. We'll talk about that in just a moment. The other way to look at it is on a map. Nope, you don't see much activity in the Eastern Caribbean in the early part of July. And the reason is because the trades usually blow real strong through here. And these tropical waves can't gather themselves. There's a lot of reasons behind it. Usually the Bermuda-Azores high is strong and fairly far to the south this time of year, and so the trades are stronger. Later in August and September, this migrates more to the north, and the Bermuda high and the subtropical ridge is up to the north here. So the trades and the pressure gradient down here relax. So these tropical waves that come off, they don't come off at 25, 30 miles per hour. They're slower, 15 to 18 tops. That's usually what we're used to seeing. So Elsa was an anomaly, and it was going against the background state of climatology, but it was definitely a sign, I do believe, of things to come, in that despite climatology suggesting, you're not supposed to see hurricanes down there this early, seeing one possibly indicates, and I think it's a strong likelihood, that we're going to have a very, very busy August and September when climatology starts to tilt more in our favor. And by that, I mean this, the ramp up that we get later in July through August and the peak time there in about mid-September. All right, so here we are now. That is why Elsa is struggling, at least a good part of it, overall. So taking a look at the satellite imagery this afternoon, there's a few other things that I can point out, and that part of that is, of course, the fact that we've got Hispaniola, big old landmass over here consisting of Haiti and the Dominican Republic, elevation through here, mountains along the Tiburon Peninsula, and that chokes off the inflow that's trying to come into this thing. Imagine that Elsa is an engine, and it is, it's a heat engine, and like the engine of an automobile, unless it's a Tesla, and that's a different story, you have to have the air intake, and if you choke that off, you start to really harm the efficiency of the engine. And the same thing with Elsa down here. A tropical cyclone has to pull that air in. And if it can do that, that's just part of the puzzle. The other part, it has to be aligned. And if everything's just moving really fast, it's hard for that vortex to be vertical. And if it gets tilted or stretched like that, either from wind shear or the lower levels moving faster than the upper levels, where it's kind of what we call apparent shear or translational shear. Shear is shear. It doesn't matter. Shear is bad for tropical systems because they have to line up vertically. That vortex has to be stacked from the 850 millibar level, the 700 millibar level, all the way up to the 200 millibar level, and everything in between. And when they do so, you can have these very powerful hurricanes. And for now, we're not seeing that with Elsa. We're also not seeing much in the way of banding. You know, it's more of these globs or blobs, whatever way you want to call it, of thunderstorms that are erupting, convection. There's clumps of them instead of organized bands. Part of that is the disruption of Hispaniola. Part of that is the translational forward motion of it, and just other mechanics going on that's preventing this from rapidly strengthening over what would normally be a lot, very high ocean heat content. I'll show you that in just a moment. Now, for our friends over here in Jamaica, you got some problems headed your way, especially if one of these big bursts happens to be over your area. And I'll show you what that can do. This is video sent to me from Lemuel Taylor down in Barbados. I'm going to play this for about 30 seconds. This was yesterday on the island of Barbados, and it shows you what those strong winds can do.
Right here in Barbados, it's 20 minutes after 7 o'clock in the morning, and Elsa has just stepped up.
And you notice, I'll mute it just for a second, there's not much rain here, and yet it's still pretty windy. You get one of these strong bursts of convection. There you go. There's a downburst right there. These gusts, you never know when those are going to happen. And over this, the elevated terrain, especially in Jamaica, and it looks like Lemuel was down closer to sea level there. He's not up on the hillside. And again, it's not raining very much in this shot. But any of that deep thunderstorm activity, and Lemuel, thank you for sending this to me, any of that deep thunderstorm activity like that right there or this over here, if that happens over you in Jamaica or over Hispaniola, you bet that can dump a lot of rain and bring that wind down very efficiently to the surface. We call that a downdraft. All that wind is blowing around in there, and these thunderstorms go up through it, drag that wind down to the surface, and you can get some strong wind gusts that can tear apart just about anything if it's strong enough. So keep an eye on that. In Jamaica, it really doesn't matter if the center gets near you. It's the storms and the rain and the bands and the globs of thunderstorms. That's what you need to be watching for, and those will all be heading in your direction over the next few hours. I was looking through Twitter, and darn it, it updated on me. I didn't want it to do that. I should have just clicked on this to save it in there. Come on, thank you. I follow this person here, TC Alert, a high school student, which is pretty cool. Hey, I'm a high school weather enthusiast. I like that. And I don't know who this is, but they post really relevant and educated information. And in the short term, it was interesting, this tweet. Elsa appears to be trying to intensify again this afternoon. Each temperature spike associated with a center pass is progressively warmer, indicative of convective bursts, strengthening the warm core through latent heat release. And I think that's relevant because you can see that happening right in here. All these thunderstorms, the lightning, that's those yellow speckles. Elsa's trying, but it's not doing a very good job against the background state and that word, climatology. All right, so let's see what the GFS shows going forward. And there's definitely some good news here compared to what we were seeing in recent days. And by the way, part of me wonders if the GFS just kind of didn't fully understand through its physics. I don't know how it works. I really don't. I mean, it's like computer-generated imagery, animation, like you see in the movies these days. I get the concept of computer modeling when they make these incredible CGI movies, but I really don't know how the heck they do it. You understand, like how the sausage is made, as they say. I generally understand the global models, but a lot of the deep math and physics, no, I don't, admittedly. So I do wonder, that being said, is the GFS not necessarily understanding, oh, darn, I forgot it's July, this isn't really supposed to happen. I don't know. I don't know how much climatology is baked into these models. I don't, and maybe I can ask somebody one day, but there's that disclaimer. I don't know everything. If I did, I would retire and become a, immunologist or something, study evolutionary biology, whatever. You get the idea. I don't know everything, and there's a reason why the GFS was suggesting intensification all through here with a hurricane for Florida, and it jumped off of that reasoning yesterday. I don't know why, it just did. So here's what we have today, and this is the 850 millibar level of the atmosphere. The initial conditions, there's Elsa down there at 8 o'clock this morning, fairly well represented in the 850 millibar field, that vorticity, the low-level vortex, as we call it. Move it out into time. This is roughly right about now, about an hour off. But then we go on out to this evening, early tomorrow morning. It's like, it really starts to look disheveled, even more so as it approaches Cuba. And then really starting to fall apart there. The vortex just stretched and hardly discernible. Crosses over Cuba, tries to make a little bit of a comeback, larger now over the eastern Gulf. And then it finally comes up into the Big Bend, practically over Cedar Key, Wednesday morning as, a tropical storm with some onshore flow, heavy rain, coastal flooding, that kind of thing. But a far cry from what this was showing. And let me just compare this to, let's just go back to 12Z Friday and show the same time frame. It was bringing in a fairly substantial storm, even yesterday morning. And let's go back even a day further to Thursday. There we go. That's my point. Look, we went from this, to this in very short order, just a couple of days' time. And I think climatology plays a big role in that. The Euro is even less enthused. This is its version. There's the low-level vorticity right there, as you can see. We move this out into time, and let me get this going. 24 hours out, practically non-existent, hung up over the Florida Straits, and then it doesn't really move much, which is kind of odd, going from 29 miles per hour to next to nothing down in the Florida Bay area, and then it's barely discernible. See, there's the reflection right there, somewhere over Orlando maybe, along the I-4 corridor. Heavy rain, some squalls, but that's about it in the Euro. And then it tries to develop off my coast, of all places. I'm telling you, it gets maddening, doesn't it? I mean, and I'm just trying to track it from the business side of things. This is what I do for a living. Trying to worry about it necessarily in your neck of the woods, whether you're in Florida, the Greater Antilles, Jamaica, Lemuel down there in Barbados, they had a pretty good idea of what was going to happen because it was coming at them and it was getting stronger, and I talked about it, that, if it was strengthening when it went over them, it would be a much bigger impact situation, and that came to fruition. But when we looked out, that was like Thursday, Friday, and then I just showed you in the longer time frame after that, we were thinking that there could be a hurricane in the Florida area. Now, that was reflected, by the way, in the National Hurricane Center discussions with that word uncertainty. They would say there is greater uncertainty than usual. There is a lot of uncertainty at days 3, 4, and 5 or whatever. They don't explicitly say, we don't know if it's going to be a hurricane or not. They don't talk in those terms. They say uncertainty, probability, and that's how that is translated. I am able to talk about it much more openly, go over the different scenarios with you, and we have a fairly educated audience here on my social media channels, and that helps. All right, so for what it's worth, the various model plots from this afternoon, some of them showing a little bit more of a westerly trajectory into the west coast of Florida, whereas the Euro, again, was kind of down here. I don't know. I mean, whatever. This is just a nice aggregate of the various models from the consensus at the top to the different globals and regional models, and then your simpler statistical models down here. One thing of note, that the envelope overall of all of the guidance is fairly small, generally indicating a threat to Florida, but that word threat, you know what I'm saying, impacts to Florida from something, whatever's left over. We'll see. One thing that is in its favor is the water temperature profile. Lots of upper ocean heat content down here between the oranges and then eventually the reds and whites. So plenty of warm water, not just at the surface, but very deep below the surface as well. The upper ocean heat content not nearly as robust in the eastern Gulf, but make no mistake, the water temperatures are definitely warm. What this shows is how deep that warm water resides in the ocean. It's not just at the surface. It's got to be a fairly deep column of warm water to give you a high ocean heat content value. because the hurricane can come along, or the storm, or the tropical wave, or whatever, just a cold front, blow across that water a little bit, and if it's just a shallow layer of warm water, it's able to mix that very efficiently and take away the latent heat and the energy source very quickly. So the Eastern Gulf is warm enough. It's just not as warm as where we're going to see it later on in the hurricane season because climatology. All right, so that's it on Elsa for now. My plans are on hold, I guess you could say. I'm waiting to see if there's something to go to Florida for. I'll go. I'll watch this just like you guys will, and I've got stuff packed. I've got my rental vehicle, and I can take it back on Monday and get half my money back. So be it. At least I've got the ability to do that thanks to the crowdfunding, that I'm able to be ready to go if needed. But if this falls apart and never recovers, I'll spend next week back here at the office in Wilmington, North Carolina, working on other projects, editing video and all sorts of other things. So I don't know yet. We'll see tomorrow, just like you guys will, all right? So we'll watch it. We'll see how things progress. At least it looks like less of an overall problem for folks in the Sunshine State, but we don't know for sure just yet. So we'll watch this closely together, and I'll update you accordingly. I am on the social media circuit, Facebook and Twitter and YouTube. YouTube has grown again very quickly as of late. I appreciate that. It's great to have all the new folks coming in on YouTube. Our Patreon support also picked up here the last few days. It makes sense. Tropics are in the news, so people are interested, and I'm glad you're interested in my work. That means a lot to me. Have a great rest of your Saturday. Stay safe out there if you're traveling or doing anything related to the 4th of July. However many digits on your hands, hopefully all 10, you have now, may you please have that many come Monday morning. All right? Little word to the wise there from a dad. I am Mark Sudduth again. Thanks for watching. We'll talk about it some more tomorrow.